Right now I'm going to explain how to do a limiting reaction problem. The first thing you need to do is figure out the balanced equation. So in this problem it says identify the limiting reactant by finding the mass of magnesium oxide produced when 2.2 grams of magnesium react with 4.5 grams of oxygen. So we have magnesium and it's combining with some oxygen. Oxygen's diatomic, so you need a little 2. And they are combining to make MgO. And magnesium is 2 plus, oxygen's 2 minus, so the formulas are written right. And now we need to balance the equation. We can do that with a coefficient of 2 here and 2 here. Now that we have a balanced equation, the next thing we have to do is figure out what we want to find in this equation. So we have 2 givens in the problem. We have 2.2 grams of magnesium, so I'm going to write that right here. Okay, that's my grams of magnesium, and I'll be converting that. And then I'm also given 4.5 grams of oxygen, so I'm going to write that here. You do write oxygen as diatomic because that's the way it shows up in the problem. Okay, now the question is, what am I going to convert both of these to? And the problem says to find the mass of magnesium oxide. So both of these problems are grams to grams. So grams of magnesium oxide goes here, and grams of magnesium oxide goes down here. So I'm going to be performing 2 grams to grams problems. In a grams to grams problem, the order always goes grams to moles to grams, to moles to grams. And the first 2 substances are the same thing. So this one and this one are the same, and then this one and this one are the same. So that'll be my top row. So if I have 2.2 grams of magnesium, I'll then go to moles of magnesium, then I'll go moles of magnesium oxide, and then finally grams to magnesium oxide. I'm going to complete the setup by putting grams of magnesium on the bottom so that it cancels out. I'm going to put moles of magnesium on the bottom so it cancels out, and finally moles of magnesium oxide so it cancels out. Now, where I have grams and moles together, I'm going to put a 1 in front of the moles. So 2 of the spots always have a 1 there. In the boxes where it says grams, right here, for instance, I'm going to find the molar mass of the element or compound. The element here is 24.31. I got that from the periodic table. And then here, in this box right here, I'm going to put the molar mass of magnesium oxide. I've already calculated that, and it's 40.30. Finally, I'm left with the mole ratio, so I look at the balanced equation. The coefficient in front of magnesium oxide is 2, so a 2 goes up here, and then the coefficient in front of magnesium is also 2, so a 2 goes here. To complete the problem, I'm going to multiply everything on the top, so I'll multiply 2.2 by 2 by 40.30. Then hit equals in your calculator. Then you're dividing by 24.31, then hit equals, and finally hit divide by 2. Do that problem until you reach the answer of 3.65 grams of magnesium oxide. That is your first answer. Okay, now we need to convert 4.5 grams of oxygen to grams of magnesium oxide. The setup is very similar. You go grams to moles to grams. And then on the bottom we do grams of oxygen, and moles of MgO. 1 always goes in the lower corner, and then this upper one. The molar mass of magnesium oxide, which we figured out earlier to be 40.30, goes here. The molar mass of 2 oxygens, which is 31.98, goes here. Then we stick in the mole ratio. A 2 goes on the top, and a 1 goes on the bottom. The 1 came from the coefficient or lack of coefficient in front of oxygen. Now we're going to multiply across, so you're going to multiply 4.5 by 2 by 40.30, hit equals, then divide by 31.98, and we'll get 11.34 grams of magnesium oxide. Now the very last step in a limiting reactant problem is to decide which of my 2 products this one or this one is the smaller number. Clearly, the top number is the smaller number. So you look at the beginning of the equation and you find out, oh, magnesium was the reactant that led to that smaller product. So then you finally write Mg is the limiting reactant. And circle your answer, and you are done.